So for sorting out the points, we need to find the limits and then get a midline of those. So what's gonna be easier to do is have the start point, the end point, and with those two, start decomposing so we can get the complete panorama. We can also use a bounding box if we want to have the limits. So I'm just gonna do it manually and then see it with the bounding box. So get the points, x and y, which are the values we want, x, y, x and y. Find minimum. Function key is gonna be minimum item of a list. Thinking that those values are actually together, if we want to be sure that lines are not reversed or have some other problems, what we can do is have a list create, which I so that if we join the x's, we know the minimum, and now the minimum then we can copy and do the same thing, but instead of minimum asking for maximum item. From those values, it's telling me it's run 0, -14, 49, 37, and 5. This is one great value. So since we know that the x values are gonna be the y values is gonna be the same, mostly the same. We want to make this line in between. We want to make it from this location to the other one. So let's get this line together. A dash function using Alex join. So with this, both values are gonna have just one single point. It's the midpoint of y. And if we should point my coordinates, we can have a y value within the minimum and with the maximum. So if it's run, it's having this point and the other one. Let's check if we have already isolated the coordinate. It's doing a line like this. We get line by start on point. We can also connect them. Oh. And that's following the path of the elements. So what we need to know here is which is the closest point for each of those lines to be set. So we can use either the start point, end point, because it's perpendicular. So the function we need to get is closest point. Closest point to this line. We can use these start points. So actually right now it's just giving me the values on the other way. But all of them are aligned. But set up that line so we can know which one comes first and which one comes at last. Since they are already like this, we can use the parameter value. Actually is parameter as point, thinking that we want to have the parameter set parameter point. So if we have the point and we have the curve, it's gonna give me the distances they have. We can see the 11 and 12 are actually on the same spot, and the other ones are being sorted out from the location. So perhaps won't see too much difference on this one because they're already sorted out. But if we do it on the opposite, let's just save this one as group, sorting grids, sorting grids, maybe yeah, sort. It will pick this type of order, is the same. Let's check it with the color line. Make it. Copy complete. Copying the complete group. But in this case, we want to change the other side, so it's gonna be being connected in Y and X with the same value. And instead of using the in, it's to be the output. So now it's showing something like this is 1027. So they are all sorted to get sorted out. So now that we have those lines being sorted out, we want to find which one is belonging to what. So that we can give them a letter or a number. Index of. Just need to be careful here because of the last value that it's just being with problems. This is unique items just to avoid duplicate. Okay, something like that. Index of. And we can have it like this, so we can have the index of, and we get rid of the last one. Yeah. Index of function. What we'll do is find out the number on the list we want. So we'll give you something like this. So when you're pulling it, you can have a definition of index. Pulling the lines. And the same thing happening down there, down here. So that they are now clearly in order. So using this folder, you can give them letters and numbers. So just gonna use a count. Count pieces will give me the number I need to get at the end. 12, going from 1 to n to the space of 1. We'll make the count from like that. Same criteria can be used from here. But instead of using, let's call it A, there needs to be with quotations. So it came like that. Capital. And if we get grids, we want to have grid. Eyeline. Then we need to change names so that they are already sorted out. Parameter is being called set parameters by name. So we have the grid parameter name will be called name. Main being connected here. Let's squiggly line, it's line. Yeah, it's the line. Actually, the mistake. Yeah, here is missing something. It says it's not a number. So remembering when we give the number to string to number, we can also do the same thing. It's modify. It's from object, I believe, generate. Here from object. So that will transform the numbers in strings. The degree here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can also extend it, checking out that ones, A, B, C, D, E. Okay, so in this case we have it on the opposite way. We're gonna make it a little step back. That means to change this sorting order, it's gonna be start point, end point. So now it goes A, B, C, D, E, F, G, H. So if we connect these curves to become a curve because they were created not by a block, they were specifically modified, which will make it a little more difficult to analyze. We can use the polycurve function to see how it behaves. So we have one that is called by joined curves. So the joint elements need to be at least something that can be full. And in review, it's creating the polycurves, but it's actually not filling in the gaps. It has already these square elements. So we can do it differently. We can have elements being pulled to be just a square, or we can separate them through the family they are requiring, or just create the geometry. So let's see the three scenarios. Okay, so thinking of this, we might want to, we can create the geometry just by the polycurves we have here. I mean, if they are already polycurves, that means that we can also copy them depending on the height we require or the elements, but what that will make it on the proper sense. So just for the goal, we're going to use geometry translate, saying that we want all of them to be a little off. Set abstract vector by coordinates. Be 5. The distance of, let's say, the distance of 5, it's 5. So all the polycurves are already on its spot. We can call it to be a single line. We can use the solids, solid being created by lofts. Then for the polycurves to be intersected, we need to have a list to create. Yeah, we're missing here a transpose because we want each one to be its coupled. So it's following the path, it's creating the geometry, it's extruding. But the problem with this is that we don't have any index of what's happening with our file. The elements are being created by CAD, but they do not hold any logic using Revit properties. We don't know how many they are, they're just single elements. And even though remembering the workflow, we can use the Yeah, we have noodles here somehow because it wasn't possible to create it. Let's see. So we can follow this path using direct shape and things like that. So the other way would be if we separate the possibilities. We can go for the use of the polycurve. The polycurve having a number specific, so we can go for a count. We know how many lines there are. You can start by the number 4s, set something like this. That one. It's pulling the truths. Or we can have 4 indices of instead of the equals. So it's giving me the numbers that actually have those elements. Get it an index. Yes, I think it's all 3. I said it, yeah. And we can select this one. So if we have those 4 lines, still they can give us the values we're requiring for creating that single steps. So how do we create those 4 elements? We can get the it's called the geometry polygon curve, polygon center. Yeah, it's actually required polygon so that we can read it and change it. So we have 4. So since this is going to be the same scenario but using the polycurves of the ones that we have already created, let's do it with all the elements. And then with all the elements, we can insert families that have the measurement we are requiring. So let's do it something simple. What we're going to have is start points, endpoints. What we want to have from here is having the point X, point Y. In this case, we don't have any Z, it's fine. For point Y, then we have both. Let's join minimum and maximum. It's maximum item. Then we can read points back. So we can have minimum with minimum, minimum with maximum, maximum with minimum, and lastly, maximum with maximum. So with that being created, now what we want to have is that all of these connections have their own logic, so I'm just gonna check that they are having the same logic. This first point, second point, and third point needs to be up. This one's need to be the fourth. So they are closing properly. Now we can do a list join. I mean, not just this join needs to be list create. And a transpose. And by doing that, we can now pull again back our geometry curves for the curve by points. We deconnect last the first as true. So if done properly, what it's showing us is that it's creating the complete figure closing the extremes. So all the squares are now rounded, all are on the same location, and we can use them to create different family elements. Speaking of that, we need to have the values, so we can create a family column. So what we can use is we can get the average of x then it's be list create. It's the minimum and the maximum of y e transpose, so they are connected one with the other one. And the same pattern with the y value, minimum and maximum, which is transpose average numbers, so that when they connect, they are already having a center point for each particular family. So we want to index them. They are already on the location. We need to know the width and the height. We can read it from the lines here. From the lines here. Or we can read it from the polycurves. So any of those paths will be the same. So let's do a line. Let's start point, end point, thinking of this one. That's gonna be the length. So it's curve length. So this is giving me the lines on one side. Everyone on the opposite side needs to be from this one to this one. I mean the other curve length. We know that there is a small difference, so let's use a math round. Math round numbers. 2 decimals would be fine. Now we have different values for those. There's 2 that are too small. It's just small, it's giving a 0 value. Yeah, it's It's not proper than this. Yeah. So we have here different values. It's fine now. So the interesting part of this is that we have already the location, we have the shape, and we can create families that are actually responding on the location and with the size that it's required from the drawing. So we already have the files, we have the elements. What is missing is to create the columns. So we're just gonna use the points. Points are gonna give me the lines we want. So it's gonna be translate. In this case, last version we use direction distance. We're gonna use just direction with a vector. Straight 5 meters. Then we have a line from down up. So those are the lines for the columns. We can see it here. And we need to place the proper type with the proper element. So in order to do it so, we need to have from the unique types the specific characteristics. So let's call it index of. We're gonna use the index element on the local list. So it's telling me which type they require. From the element type, we can ask for here element index. And the only thing missing here is to create the column. So for creating columns, we have Revit elements. And as I told you before, all the element creation methods are here separated on the category they belong in. So for this sample, we can use the structural framing column by curve. We have the curve, we have the structural column type. We're missing the levels, so we can go for a selection and just pick a direct level. Let's pick level 1. Remember the first thing I tell you about levels, just a small, would be good to know that they are on the proper location. So if we review now, everything's built from CAD. We're having a problem with location. So all of them are twisted on the opposite sides. So I think need to cross 10. Number and number. Let's say. Yeah. So now they are free. Same location, same type of settings. So all of them are on the size. And the good thing, well, we have perhaps too many elements on the concrete because we made the cross. Just gonna delete all of them. Run again. If it's not creating them, stop creating it because we don't have the type. Just gonna save columns from that. Close it, open it again. Check that the family type is selected from here. Concrete rectangular on the way to convert, and then we can run. Now they are already set, and we just have numbers that we are requiring.